In this class, we'll discuss about VLDL metabolism. This VLDL metabolism is important in transport of endogenous triacyl glycerols from liver to peripheral tissues. From liver to peripheral tissues. And these VLDL molecules will require EPO B100 and triacyl glycerols for their formation. Now, in hepatocytes, we have polyribosomes. Polyribosomes. These polyribosomes will help in synthesis of ApoB100, and this ApoB100 is transported into the lumen of endoplasmic reticulum. This is lumen of endoplasmic reticulum, and we have a special protein called as MTP. This MTP is called as microsomal triglycerol transport protein. This MTP will help in causing lipidation with phospholipids of ApoB100, and this MTP will also help in transport of triglycerols from cytoplasm into the endoplasmic reticulum lumen, and these triacyl glycerol are also incorporated, and they will help in formation of a molecule called as VLDL2. These molecules are called as VLDL2 molecules. Now these VLDL2 molecules will be incorporated into a special type of vesicles called as COP2. These are called as COP2 vesicles. These COP2 vesicles, they are called as coat protein 2 vesicles, and they help in transport of these VLDL2 molecules into the Golgi complex. This is a lumen of Golgi complex, and these VLDL molecules are transported. This is Golgi complex. Now these VLDL2 molecules will take up triacyl glycerols and phosphatidic acid. This is phosphatidic acid. This acid is also incorporated into the VLDL2 molecules, and now they will form VLDL molecules. These are called as VLDL1 molecules, and these VLDL1 molecules will be released into the circulation. Now these molecules are called as nascent VLDL. Now this triacyl glycerols, which are incorporated into Golgi apparatus into VLDL2 molecules and VLDL1 molecules for the formation of VLDL molecules. These triglycerols will come from fat-rich diet, and they will come from fatty acid synthesis due to excess carbohydrates, and again these triacyl glycerols will come from remanent chylomicrons. Okay, these VLDL molecules will have different apolipoproteins. So one is ApoB100, they will have ApoC and ApoE. Okay, they will have ApoB100, this is ApoB100, and this is ApoE, and this one is ApoC. Okay, in this nascent VLDL, major contribution is by the triacyl glycerol. They'll have more amount of triacyl glycerol, then cholesterol ester, then cholesterol. This is called as a nascent VLDL, which is released from the hepatocyte. Now, this nascent VLDL will be converted into mature VLDL. How this is converted into mature VLDL? We have an molecule called as HDL. This HDL will have ApoC, and this ApoC is nothing but ApoC2. ApoC2. This is ApoC2, and one more molecule is ApoE. This is ApoE. ApoE. And these ApoC2 and ApoE will be transported to the nascent VLDL molecule, and this nascent VLDL molecule will become a mature VLDL molecule. And this mature VLDL molecule will have more amount of triacyl glycerol, cholesterol ester, and cholesterol. Now they will have ApoB100 and further ApoC2 and ApoE. This is ApoB100. This is ApoE. This is ApoC2. Already nascent VLDL have little quantities of ApoC2 and ApoE, and major contribution is done from the HDL. This ApoC2 and ApoE, major ApoC2 and ApoE are contributed by HDL to the VLDL molecule so that they will become a mature VLDL. Now, what is the function of ApoC2? What is the function of ApoC2? They will activate lipoprotein lipase. ApoC2 will activate lipoprotein lipase, which causes hydrolysis of triacyl glycerol into fatty acids, and these fatty acids are taken up by the peripheral tissue. Now, these mature VLDL will release triacyl glycerol, and these triacyl glycerols are broken up into fatty acids by the lipoprotein lipase, which is activated by ApoC2, and these fatty acids are taken up by the peripheral tissues. And these VLDL molecules with a loss of triacyl glycerols, they will have less quantity of triacyl glycerols and more quantity of cholesterol ester, and less quantity of triacyl glycerol. Now, this ApoC2 will be again transported back to HDL. And this VLDL molecule will have only ApoB100 and ApoE. This is ApoE, and we have only ApoB100 and ApoE. So ApoE, which is taken up by the VLDL molecule from HDL, is retained, and this VLDL molecule is called as remnant VLDL. Remnant VLDL. Now this remnant VLDL has different fates. We have VLDL remnant. VLDL remnant. So this VLDL remnant molecule will have cholesterol ester, cholesterol, triacyl glycerol, and they will have ApoB100 and ApoE. ApoE. This is ApoB100 and this is ApoE. Now this VLDL remnant molecule will have two fates. One is this ApoE molecule will be sensed by ApoE receptors. So they will be transported to liver. In liver we have ApoE receptors. These ApoE receptors will bind with ApoE on VLDL and they will cause endocytosis of remnant VLDL molecule and causes degradation. Now after degradation, they are degraded into smaller particles, and 50% of the remnant VLDL will be transported through the receptor mediated endocytosis. Next, remaining half of VLDL, this is 50%, remaining 50%, they will reach liver, and this ApoE receptors will bind to the liver. On the liver, they are processed by hepatic lipase. What this hepatic lipase will do? This causes loss of triacyl glycerol. The small part of triacyl glycerol which is present in the remnant VLDL will be removed from the VLDL remnant molecule, and there is a loss of triacyl glycerol. Now the molecules will have only cholesterol ester and cholesterol, and the ApoE which is present in the VLDL remnant, this ApoE is transported to HDL. Transported to HDL. Now an intermediate product is formed with only ApoB100. Only ApoB100 is present and ApoE is transported to HDL. And only cholesterol ester and cholesterol is present in this molecule, and this molecule is called as, first it is called as intermediate density lipoprotein, and this intermediate density lipoprotein is converted into a final product called as LDL. This is called as LDL. So they'll have cholesterol, esters and cholesterol, and with only ApoB100. ApoB100. This is how final product of VLDL is formed, which is LDL. So this LDL molecule is rich in cholesterol, either in the form of cholesterol ester or cholesterol. This LDL molecule will transport cholesterol from liver to peripheral tissues. Liver to peripheral tissues. This is the metabolism of VLDL in brief. Okay. Thank you.